Ah, helicopter flight, it's truly a marvel of modern engineering. These machines are not just about brute force, they are about finesse and precision. These incredible machines can take off and land vertically, hover motionless in the air, and even fly forwards, backwards, and sideways. This versatility makes them indispensable in various fields, from rescue missions to military operations. But, this amazing agility comes with its own set of challenges. Pilots must be highly skilled to handle these complex maneuvers. Helicopters are inherently unstable aircraft by design. Without constant input, they can quickly deviate from the desired attitude. This requires pilots to be always on their toes, making real-time adjustments. Piloting a helicopter requires continuous, precise adjustments. The pilot has to manage multiple controls simultaneously, including the cyclic, collective, and anti-torque pedals. Each control affects the helicopter's movement in different ways. Even small gusts of wind can upset the helicopter's balance, demanding high concentration and skill from the pilot. It's a constant battle against the elements and the machine's own tendencies. The quest for improved helicopter stability has been ongoing for quite some time. From the early days of aviation, engineers have sought to tame these wild machines. Engineers have worked for decades to make helicopters easier to fly. Their innovations have made modern helicopters far more stable and reliable. This lesson, Lesson 21, will explore these important systems. We'll delve into the technology that keeps helicopters stable. We'll focus on Stability Augmentation Systems, or SAS. These systems are the unseen hand that helps pilots maintain control. Stability Augmentation Systems, commonly known as SAS, are absolutely vital. They are electronic or electromechanical systems in a helicopter, and their primary job is to improve the aircraft's stability. SAS assists the pilot in maintaining control by sensing and counteracting small, unwanted movements. Think of SAS as a system that smooths out the ride. SAS makes the helicopter feel more stable, giving the aircraft better handling qualities. SAS achieves this by making rapid, minor adjustments, often to the flight control system. The pilot might not even be aware of these small corrections, but the overall effect is a more stable and manageable aircraft. SAS acts as a crucial aid to the pilot. Understanding SAS is fundamental to understanding modern helicopter operations. The primary purpose of SAS is to reduce pilot workload. SAS helps by automatically damping out short-term disturbances, meaning the pilot has to make fewer corrections. SAS significantly enhances the aircraft's short-term dynamic stability. Dynamic stability refers to how an aircraft responds over time to a disturbance. SAS senses these tendencies at their very onset and applies corrective inputs to dampen these motions. Another key role of SAS is to improve handling qualities. SAS contributes by making the helicopter respond more consistently, and it can make a naturally unstable helicopter behave like a more stable one. SAS helps prevent undesirable aircraft motions, such as porpoising or Dutch roll in some aircraft types. The contribution of SAS to overall flight quality is immense. Section 4. Force Trim Systems, holding steady against the elements. One common type of stability assistance in helicopters is the force trim system. This system is crucial for maintaining control and reducing pilot workload, especially during long flights or in challenging weather conditions. Force trim is designed to hold the cyclic stick in a set position, allowing the pilot to focus on other critical tasks without constantly adjusting the controls. When the pilot finds a desired flight attitude, they can engage trim. This is particularly useful during extended periods of straight and level flight. The system then uses magnetic brakes or springs to keep the stick in place. These components work together to ensure the cyclic remains steady, even in turbulent conditions. This means the pilot doesn't have to constantly hold pressure on the controls, which can be physically demanding over time. It effectively trims the control forces to zero for that attitude, making the helicopter easier to manage and reducing the risk of pilot fatigue. The operation of a force trim system is quite straightforward. The pilot maneuvers the helicopter to the desired pitch and roll, then presses a button on the cyclic grip to engage the force trim system. The pilot maneuvers the helicopter to the desired pitch and roll, then presses a button on the cyclic grip to engage the force trim system. This action locks the controls in place, allowing for a more relaxed flight experience. The main benefit of force trim is reducing pilot fatigue. By minimizing the need for constant manual adjustments, the pilot can maintain focus and energy levels throughout the flight. Force trim allows the pilot to relax their grip somewhat, which is especially beneficial during long missions or when flying in challenging conditions. It makes a significant difference in pilot comfort and endurance, contributing to overall flight safety and efficiency. Force trim also helps in maintaining a precise flight path, ensuring that the helicopter remains on course with minimal effort from the pilot. Section 5: Active Augmentation Systems, Sensors, Actuators, and Seamless Stability. Active Stability Augmentation Systems go a step further than force trim. These systems actively sense and counteract aircraft motions. They make continuous, small adjustments to the flight controls. Active SAS uses a suite of sensors to detect any deviations. It then uses actuators to apply the necessary corrections. This creates a very stable and responsive flying platform. Sensors, such as gyroscopes, detect angular rates of motion. Accelerometers can detect changes in speed or direction. These sensors feed information to a computer, which processes this data to understand the helicopter's state. Once the computer determines a correction is needed, actuators come into play. The beauty of active SAS is its seamless operation. It works in the background without requiring pilot intervention. Section 6: SAS in action aiding pilots in demanding missions. The benefits of SAS become particularly clear during demanding missions. Consider long cross-country flights, for example. Without SAS, the pilot would face hours of intense concentration. SAS significantly reduces this workload and associated fatigue. This allows the pilot to remain alert and focused on navigation. Search and rescue (SR) missions often involve operating in harsh conditions. SAS helps to stabilize the helicopter, especially in the hover. Flying under instrument flight rules (IFR) is another area where SAS shines. In IFR conditions, the pilot has no external visual references. SAS helps to keep the helicopter stable and on the intended flight path. Beyond these examples, SAS aids in many other pilot operations. By reducing the effort needed for basic stabilization, SAS frees up the pilot. Section 7: Conclusion: The enduring impact of SAS on modern helicopter aviation. Stability Augmentation Systems have fundamentally changed helicopter aviation. These systems, often abbreviated as SAS, are designed to enhance the stability and control of helicopters, making them safer and more reliable. By making helicopters easier to control, SAS reduces pilot error. This reduction in error is crucial, especially in challenging flight conditions where precision and quick response are vital. The unseen hand of SAS constantly works to keep the aircraft steady. It adjusts the rotor blades and other control surfaces in real time, counteracting turbulence and other destabilizing forces. This provides a more forgiving environment for pilots. They can focus more on the mission at hand rather than constantly battling to keep the helicopter stable. Beyond safety, SAS has greatly expanded helicopter capabilities. Pilots can now perform complex maneuvers and operate in environments that were previously deemed too hazardous. Missions that were once considered too risky or difficult are now routine. This includes search and rescue operations, medical evacuations, and military missions in hostile territories. The precision afforded by SAS is crucial for specialized roles. Whether it's landing on a moving ship or navigating through dense urban environments, SAS ensures accuracy and safety. Today, virtually all modern helicopters are equipped with some form of SAS. This widespread adoption underscores the importance of these systems in contemporary aviation. From light trainers to heavy-lift transport helicopters, these systems are standard. They are integral to the design and operation of modern helicopters. Aspiring pilots will find SAS integrated into their training from early stages. This early exposure ensures that new pilots are well-versed in using these systems effectively. Looking to the future, SAS technology continues to evolve. Innovations in this field promise even greater stability, control, and safety for the next generation of helicopters. Its enduring impact is clear. SAS has made helicopters safer, more capable, and more versatile. As technology advances, the role of SAS in helicopter aviation will only become more significant.